Hi, hello everyone. This is your educator, your tutor, your friend Sanjay Kumar Vishwakarma. I welcome you all to yet another session of We Learning. We Learning is a platform which focuses on providing right to quality education for all. Do watch this session. If you like it, do press the like button. Share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. And also do not forget to visit our website www.we-learning.in. Alright, all these lectures you will be getting there. Along with that, you will be getting lecture notes also. Okay, do check it out. Alright, so now without any delay, let's get started with today's session. We were doing current electricity and this is lecture number 5. In this lecture, we are going to talk about electrical energy and electrical power. Now, this is something which you have already studied in your 10th standard. Today's lecture is not going to be anything new for you. It is completely similar to what you have already studied. Alright, so yeah, it's a kind of a revision for you all. Okay. Now, electrical power. What is power? For people who know, it's good. For people who don't know, let me try to explain you from a very normal example. Suppose there are two people, Ram and Sham, both are climbing tree. Fine. Both are having same energy. Now Ram is taking more time to climb the same height and Sham is taking less time to climb the same height. Both are putting same amount of energy, but the time taken by both of them is different. Ram is taking more time, Sham is taking less time. So whose power will be more? The one who is taking less time, right? Because in less time only he climbed. So the power is more. Understand, work done per unit time is power. The work done by both of them was same, but time taken by Ram was more. So we'll say he is having less power, and time taken by Shyam was less. So we'll say he is having more power. Clear? So electrical power, it is defined as the rate of electrical energy. Rate of electrical energy means electrical energy per unit time supplied to maintain the flow of current through a conductor by a voltage source. Clear? If you want, you can note down the definition. In boards, they'll ask sometimes the definition. Okay. So now, try to understand this. Suppose this is a part of a circuit. This is not just like this much. It is complete. Some conductor is there or some resistor is there. It is like this. Okay. I have shown you a part. If you see this, let's say the current is flowing like this. So the charge is also flowing like this. Correct? Either I can say Q or I can say I. Right? Potential difference applied by battery is V. If I want to write power, how will I write? For writing power, I need to know energy, because energy per unit time. What is energy? The work done by the battery. Work done by battery or energy supplied by battery is same. Same thing, right? So now work done by battery. If we know the potential difference, we can write the work done. We know that potential difference. See, here it will be V, here it will be 0. Correct? Potential difference, that is V minus 0, is equal to work done by external agent divided by charge. This is the very basic definition, first definition which we studied potential when we studied potential, right? We studied this. So now from here, I can write work done by external agent is equal to Q into V. What is external agent here? The battery. Right? Does battery supply charge? No. It provides energy to move the charge. Correct? It is that external agent which is moving the charge. So here, this work done by external agent or work done by battery is QV. Fine. Work done by battery is equal to Q into V. Power, work done by battery per unit time or energy supplied per unit time. Energy is nothing but this is delta U only. Correct? Delta U is equal to work done by external agent or the battery, that is QV. Delta U by T, that is QV by T. Yes or no? And what is Q by T? Charge per unit time, that is current. So here, writing it as current, this will be V into I. Q by T is equal to I. Alright. So power is potential difference into the current. All right, how much ever current is flowing through this in this wire, and how much ever potential difference the battery is providing. The product of that is power. Very easy, note it down. Now, if suppose a resistor is there here, so how much power this resistor is absorbing, or how much power is being dissipated here? The power which is supplied by the battery, the same power is dissipated here, right? So if you want to write this power which is dissipated here in the resistor, you can convert that V in terms of R, you will get a formula. You can convert that I also in terms of R, you can get one formula. So total 3 formulas you will get, one this and 2 in terms of resistance. We will talk about that formula later on, okay? Now this particular process where the current is flowing in this direction from this bigger line like this, okay, this is the very general case where which we see every time we connect a battery, we will take out the current in this direction only, right? This particular thing is known as discharging. Battery is discharging. When battery is discharging, the power what we get is power supplied by battery. Power supplied by battery. Fine. This battery is discharging because it is rotating the charge and giving it to the resistor, the capacitor, whatever is connected to the circuit, right? Now, if the current is flowing in the opposite direction, let's say this is the case. This is the case. Very rare you wouldn't have seen till now because no questions are formed in this particular scenario for you, right? This is battery is charging. You might have seen inverters at your home, right? When the electricity is gone, then we switch on the inverter, battery is connected to that. That battery starts providing the current, correct? And when the electricity comes, then that electricity starts charging that battery. That is the same thing. So this is getting charged. So when this is getting charged, then what is the power? It is absorbing. So here, when it is discharging, it is supplying the power. When it is charging, it will absorb the power, or the power will be dissipated here from the bigger source, right? So now, power absorbed by battery we have to find. Very simple. This time current is flowing like this. Potential difference will be like this, okay, because it will be charged to maximum potential V only, correct? From here if you see, V 0 minus V is equal to work done. There V minus 0 was work done. Here 0 minus V will be the work done by the battery, or you can write V minus 0 as work done by the bigger source. That will be negative work done by this. You can write any which ways, right? So this will be work done per unit charge. So now work done is equal to minus Q into V, correct? Power is equal to work done per unit time, that is minus QV by T, that is equal to minus VI. This is power absorbed when the battery is charging. Power absorbed. All right, by the battery. So very simple. When battery will supply, it will be P is equal to VI. When battery will get charged, then it is minus VI, opposite. Okay, easy. Next, power absorbed in resistor. Again, very simple. This is a resistor, current is flowing like this, let's say. Okay, potential difference is V. We know that P is equal to VI. As I told there, The same battery is connected to the resistor. So how much ever the battery is supplying the same, the resistor is absorbing. So the power the resistor is absorbing, or we can say power dissipated in resistor, anything. Clear? Because this power which it is absorbing is anyways dissipated only. Okay. So now that is again VI only. So if I want to write in terms of resistor, what I can do? Two ways. Either I convert this V in terms of R, or I convert this I in terms of R. So once I convert this V in terms of R, this will be P is equal to V in terms of R means IR. I into R, and one more I is there here. So this will be I square R. That is the power. Fine. Or what we can do? P is equal to VI. Here if I convert this I in terms of R, this will be V by R, correct? So that is V square by R. So there are total three formulas. This, or this. Okay, note it down. Power dissipated in resistor. Next, electrical energy. Again, we know what is electrical energy, work done by the battery to move that particular charge in the circuit. Okay. It is the total work done in maintaining the current in a conductor by the voltage source. If you want, you can note down this definition. If you want, you can note down this definition. Now see, power is equal to, from power we will get the energy. Power is equal to energy per unit time. That is equal to dE by dt. dE by dt. Now from here, dE is equal to P dt. Again, this formula is important for the people preparing for their competition. Okay. At the end, we will get one formula right now, which is given in your book. For boards, you can use that formula, but people preparing for their competition, I would recommend to remember this particular formula. Why? Understand. See, dE is equal to P dt, correct? Power is equal to I square R, right? Putting this here, this will be dE is equal to I square R dt. I square R dt. Alright. Now, or instead of this, remember this one. People preparing for their competition. Fine. Right now, in majority of the cases in boards, I is constant, right? In 90%, 95% of the cases, I is constant. So when I is constant, if I is constant, now E is equal to, we'll do integration both the sides, right? Or you can remember this way also. Remember this. So E will be equal to, I square will come out of this integration sign, R will also come out, R is always constant, integral dt. What is integral dt? Here it will be integral dt, correct? That is I square R into T. This is the energy. This is the energy. Now if I is not constant, if I is dependent on time, then we have to put, let's say I is equal to 2t. So we'll put 2t here, that will become 4t square, then t square dt. Integration of t square dt will be t cube by 3, correct? So that will be 4 r t cube by 3, 4 by 3 r t cube. Right? The formula will only change completely. So if I is dependent on t, then this formula will not be correct. That's the reason if you are preparing for competition, remember this one. Okay, integral d is equal to integral I square r dt. Now if I is constant, again you can derive till here. If I is not constant, you can derive from here. Okay, but this is important for boards. Majority of the times this formula will only be used, so don't worry, note it down. Now again, if I convert this r in terms of v, see P is E is equal to I square RT. This is one formula. Or E is equal to, if I change anything, let's say I'm changing this IR as V, okay? This I, there are two I's, right? This is IRT. So now if this IR I convert as V, this will be VIT. One formula is this. Or E is equal to, if I convert this I as V by R, V is equal to IR, I is equal to V by R, correct? So if I convert that I as V by R, what I'll get? V square by R into T. These are three different formulas. If you see, basically, this is power I square R into T, power into time. This is also power VI into T. This is also power V square by R into T. These are the three formulas. Okay. If current is constant, then these are the three formulas. Done. Now, let us see power rating of an appliance. Again, this is also something which you have already studied in your 10th standard. Okay, just a revision of that. Power rating, in every appliance you would have seen, suppose there is a bulb, you would have seen something written like this, right? It can be anything. It can be 80 watt, it can be 90 watt, it can be 100 watt. Just an example I have shown. Something like this is written. What does this mean? What does this mean? This means that if 220 volt potential difference is applied on this particular bulb, this will glow with 100 watt power, or this will absorb 100 watt power, or 100 watt power will be dissipated in this bulb. Clear? Suppose I connect it with a source of 220 volt. Then the power dissipated here will be 100 watt. Or the power taken out from the battery, the power supplied by the battery will be 100 watt. Alright. Now if I supply less voltage, will the power will be 100 watt? No. No. Okay. This only means that if 220 volt is supplied, the power will be 100 watt. Power dissipated will be, or power absorbed in this bulb will be 100 watt. Now the more power is absorbed, the more brighter it will glow. Clear? Remember that. If the potential difference applied is 220 volt, the power absorbed by the appliance or by the bulb here will be 100 watt. Clear? Will be 100 watt. Now the more is the power, this you have to remember. The more is the power, the brighter it will glow. Sometimes you get question in exams, which one will glow brighter, right? The more is the power, the brighter it will glow. That's why when we go in shop, we see the power, we see the watt, right? This much watt, give me this much watt bulb, give me this much watt bulb. The more is the power, the more brighter it will glow. Next, let's see this. Suppose this is a bulb. I have connected it to 110 volt supply. What will be the power? How will we do this? Will the power be same? No. Because if it is connected to 220 volt, the power will be 100. But here it is not connected to 220 volt. It is connected to 110 volt. The power will change. How the power will change? Okay, if we change the supply, what will remain same? See, current will also change, right? If we change the supply here, it is connected to 220 volt, the current will be more, right? Here it is connected to 110 volt, the current will be less. So current potential difference, if you change, current will change. What power will also change? What is there which will not change? Resistance, because it's a material property, right? Resistance will not change. So here, if you want to take out the resistance of this bulb, we know that P is equal to, V is given, V square by R. P is given, V is given. Can I take out R? R is equal to V square by P, that is equal to 220 whole square by 100. How much is it? 484 ohm. Correct? The same resistance will be here also. Resistance is equal to 484. Now we know resistance, we know voltage. Can I write power? Yes. Power is equal to V square by R, that is 110 whole square by 484. That is equal to 12100 divided by 484. 1 to 1 hundreds are, 1 to 1 fours are. 100 by 4 is 25 watt. 100 by 4 is 25 watt. Clear? This bulb, if we reduce the voltage, the bulb will, the power dissipated will be 25 watt. That means, I told the more the power, the brighter the bulb will glow. Here the bulb will not glow brighter. So sometimes in our house, when the bulb becomes dim, what we say? Voltage is low today, right? So this is the thing. See, voltage is low, that's the bulb will glow dim. It will be dim. All right? Easy? So always remember, whenever you get any question like this, where the power rating is given to you, the very first thing what you have to do, remember, make a note of it. Whenever the power rating is given, the very first thing you are going to do is take out the resistance. That's all. Once you get that, the question becomes easy. Okay? This means, if power rating is given in the question, this means that they have given the resistance. All right? This means they have given everything. Now see, next. Let us see some certain questions. The concept today, what we studied is electrical power, 3 formulas, electrical energy, 3 formulas, and power rating. Okay, let's see the questions. If current through a 5 ohm resistor is 4 ampere, find the energy absorbed by it in 3 seconds. Halwa question, right? See, current through a 5 ohm resistor, R is given to be 5 ohm. Now these are very easy questions. I shouldn't be doing this, but I have to do this. Okay. Current is equal to 4A. Find the energy absorbed by it in 3 seconds. Time is equal to 3 seconds. Current is constant, so I can use the formula which we have taken out. E is equal to I square R into T. That is equal to 4 whole square into R into T. 16 5s are 80 into 3 240. 240 joule. I hope the calculation is correct. Just check. If not, the main thing is concept. I hope you understood that. Okay. Next. If current through a 5 ohm resistor is 4t ampere, where t is the time in seconds, find the energy absorbed by it in 3 seconds. Now this time, the current is 4t ampere, where t is the time in seconds. Current is dependent on time. Current is not constant. See, resistance is equal to 5 ohm. Current is equal to 4t. Time is equal to 3 seconds. This does not mean that you will do this E is equal to I square RT, then here you will put 4t whole square RT, then this will be 16t square RT, then this will be 16t cube into R, then t you will put as 3, so 16 into 3 whole cube into 5. So whatever is the answer you'll get. This is wrong. This is wrong. What you have to do when the current is not constant, remember the formula, dE is equal to integral dE is equal to integral I square R dt. Put I, whatever is given, 4t, so this will be 4t whole square R dt. Correct? E is equal to, from here, E is equal to 4 will come out, 16 will come out as a constant. It is a square, right? 16 will come out as constant. R will come out as constant. T square dt. 16R t square dt is the integration. That is 16R t cube by 3. Correct? Limit for time is 0 to 3. That is 16R, or let us put the value of R. R is how much? 5 ohm. 16 into 5 into 3 3s are 9 3s are 27 by 3. That is equal to minus 0. That will be, I hope you understand, this will be this minus 0. It is like this. So this is 3 3s are 3 9s are 27. 16 5s are 80. 80 9s are 720 joule is the answer. Clear? 720 joule is the answer. Note down. So remember this, whenever current is not constant, it is dependent on time, always use this particular formula. Next, in the given circuit, find the energy spent in 2 ohm resistor in 3 seconds. So this is the 2 ohm resistor. In 3 seconds, how much energy is spent in this? We have to find out. Second, energy spent in complete circuit in 3 seconds. How will we do this? How will we do this? See, understand. For finding out the energy, what all we need? If the resistances are in series, that means what will be same in this entire thing? Current. So we need to find current. This will be, let's say, I1, this will be, let's say, I2. Fine. Energy is equal to I square RT, or energy is equal to V square by RT, or energy is equal to VIT. Correct? Now first they are asking energy spent in 2 ohm resistor in 3 seconds. In this resistor I want energy. For energy, can I put this formula here? VIT? I can put, but understand, potential difference across this will be 10 volt, across this will also be 10 volt, both are in parallel, these both lines. So here it will be 10 volt, here it will be 10 volt, correct? But for this individual, again, I have to find how much potential drop happened here and how much potential drop happened here. More calculation I have to do to find the potential drop, right? Then I have to find the current also. So two things I have to find to get the energy. I am already having resistance. If I just find the current, I'll get the answer. So finding two things will take less time, or finding only one thing will take less time? Finding only one thing will take less time, correct? Understand. So here let us find the current I2. How much will be I2? Potential difference across this is how much? 10 volt. Total resistance in this line is how much? Series 6 ohm, right? So I2 will be equal to 10 by 6. Or yes or no? Directly I am doing, okay? There is no need to write this is R1, this is R2. Since they are in series, R net is equal to R1 plus R2. I hope, correct? It's not necessary. So now I2 is equal to potential difference across this upon the total resistance. The same current will flow through both the resistors, correct? So this will be 5 by 3 ampere. 2 5s are 10, 2 3s are 6. 5 by 3 ampere. So here the current what is going is 5 by 3 ampere. Current I know, resistance I know. I can write the energy in 2 ohm resistor, that is equal to I square RT 5 by 3 whole square into 2 into time is 3 seconds. So that is equals to 5 5s are 25, 1 3 will be cancelled, 25 2s are 50 by 3 joule. Correct? Just check. 5 5s are 25, 25 2s are 50, here 9, 3 and 3 will be cancelled, 50 by 3 joule. This is energy spent in 2 ohm resistor, or energy absorbed by 2 ohm resistor, or energy dissipated in 2 ohm resistor, anything you can say. Now, energy spent in complete circuit. How will we do this? See here, we know this voltage. If I get the current, how much current is flowing in this entire circuit? This is distributing as I1, I2. Again, this will come as I and go here. So current flowing through this battery and the potential difference. If I multiply V into I into T, this formula. V we already know, only we have to find out I. Right? Or second way, what you can do, find the energy spent here, find the energy spent here, find the energy spent here, add all the energy. Again, you will get the same answer. Okay, as this one. So anything, whatever you like, you can do it, but I feel finding the current and just multiplying it by voltage and time will be easy. So let us find the current. For finding the current, let us find the equivalent resistance. Here it is 6, here it is 3. So in one branch, it is 6 ohm, another branch, it is 3 ohm. See, we will be studying about combination of resistance in the next session. But this is very basic, which we already know since 10th standard. Correct? So this will be, R net will be how much? 6 into 3 upon 6 plus 3. I hope you know this. When two resistors are in parallel, what we do? R1, R2 upon R1 plus R2. So this will be 6 3s are 18 upon 9, that is 2 ohm. 10 volt. Current will be 10 by 2. V by R, right? R is this 10. This will be 5 ampere. So energy is equal to V into I into T, that is 10 5s are 50 3s are 150 joule. 150 joule. Alright? Easy? You can try adding energy spent in all the resistors, you will get the same answer. If you want to cross check, you can do that. Or if you want me to do, I'll do that. See here. Here the current is 5 by 3 ampere in both of these resistors. In this resistor, how much will be the current? The potential difference across this is 10. Resistance is 3, so current will be 10 by 3 ampere. See, 5 by 3, see here, this is just I'm showing you. Energy spent in 4 ohm. 5 by 3 whole square into 4 into time. 5 5s are 25, 4s are 100 by 3, because 1 3 will be cancelled. Energy spent in 3 ohm resistor. Current is 10 by 3. So 10 by 3 whole square into 3 into 3. That is 100 joule, I think. 3 will be cancelled. This is 10 by 3. Correct. All right. So now here see, total energy is equal to all the three energies, energy spent in 2 ohm plus energy spent in 3 ohm plus energy spent in 4 ohm. That is equal to this is 50 by 3 plus 100 by 3 plus 100. Correct. So this is 150 by 3. 100 plus 50, 150 by 3. That is 50. 50 plus 100, 150. Same. Alright. So any which way you can do. For finding the total current also, there was no need to find the net resistance. See here. I2 we had already got 5 by 3 ampere. Just take out this I1 and add them. I1 is also 10 by 3. Easily you can find. 5 by 3 plus 10 by 3, 15 by 3, 5 ampere. 5 ampere. So there was no need to find net resistance also. You can find I1, I2 and you can get this. Alright. The only thing what you should know is in parallel, the potential in both these arms will be same. Very basic question. Next. Which bulb will grow brightest in the given circuit? Now see, this kind of question, you should know how to do this. 220 volt is supplied, power rating is given, 220 volt 100 watt, 220 volt 50 watt, 220 volt 25 watt. 220 volt is supplied from the battery, which bulb will glow the brightest? Some people will be like, sir, you told the more the power, the more will be the brightness. Here this is having the most power, so this will be the brightest. Wrong. This will not be the brightest. It can be the brightest, but you cannot tell just by seeing this. Why? Because all are connected in series, right? Since all are connected in series, this voltage 220 volt, this bulb will not get entire 220 volt, right? If this will get entire 220 volt, what will these two bulbs get? Voltage is distributed, if you remember, in series. This will be having V1, this will be having V2, this will be having V3. The sum of all the V's will be 220 volt, correct? Some voltage this will take, some this will take, some this will take. So this is not taking full 220 volt, so this will not give full 100 watt power, correct? Neither this will give full 50 watt, neither this will give full 25 watt. It depends how much voltage they are getting, how much potential drop is happening across them, right? Let's see. There is no need to find potential drop. I told you, whenever you get this kind of question, power rating is given, the first thing what you have to do is find the resistance. RA is how much? V square by P. V square by P. Okay, so that is 220 whole square by 100. Acha, resistance is constant, right? So don't worry how much voltage it will get, since this will be V1, this will be V2, this will be V3. Don't think I'll be do V1 square by this power. No. If you are doing V1 square by power, then that power should be when this V1 is supplied, right? Getting? Then also you'll get the same resistance, because resistance is constant. Because if V1 is the potential drop, then the power what you'll get will be P1, some other power. It will be according to that only. Fine. So now RA is equal to this. Resistance is always constant. RB is equal to 220 whole square divided by 50. RC is equal to 220 whole square divided by 25. Which resistance is highest and which resistance is lowest? Can you tell? In denominator, this is the least value, so this is the highest resistance. RC is greater than RB is greater than RA. Now, See, power P is equal to, in series what is constant? I. The current flowing through all these bulbs will be same. So I can write power is equal to I square R into T. If I want to get power for each bulb, resistance I have already got, not T. Resistance I have already got. Current is same for everyone. So from here, if current is constant, what I can write is P is directly proportional to R. Understand? If current is constant for all three, P is proportional to R. The more is the resistance, the more will be the power. That means, and the more is the power, the more is the brightness. So here RC is the greatest. So we can say power in C will be greater than power in B will be greater than power in A. So power in C is most, right? So C, this will glow brighter, brightest. Brightest. All right. Note it down. Next. Which bulb will glow brightest in the given circuit? This time all three are connected parallelly. Some potential is applied, let's say 220 volt. Anything it can be, okay? Now from here you can understand, for all the three, potential is going to be same. How much will be the potential? 220 volt. The same potential. So in 220 volt this is 100 watt, in 220 volt this is 50 watt, in 220 volt this is 25 watt. So this will glow the brightest. From looking at this you can understand this. Now suppose some other voltage is given. Let's say 250 volt is given. Now potential across each will be same. All right. Now understand, let's say some V voltage is there. Some V voltage. Resistance, first thing, is equal to 220 whole square by 100. RB will be 220 whole square by 50. RC is equal to 220 whole square by 25. Correct? RC is greater than RB is greater than RA. Inversely proportional, because these are same. Okay. Now, see, one more thing, whenever you get these kind of questions, to compare, only the comparison is there. Never calculate the resistance. Only write in this way. You can understand which is more, which is less, right? Because the numerator is same for everyone. Now you just have to compare the denominators, according to which you can just write the comparison. If you try to calculate, it will take a lot of time. No need. Okay. Now here, what is same for everyone? Potential difference. So P is equal to V square by R. Whatever is same, write the power in that particular term. Okay. P is equal to V square by R. V square is constant for everyone. From here, P is inversely proportional to R. There P was directly proportional to R. Here P is inversely proportional to R. What does this mean? The more is the resistance, the least will be the power. That means it will glow dim, right? And the least is the resistance, the most will be the power, it will be the brightest. So here, since RC is greater than RB is greater than RA, what does this mean? This means power of A is most, then power of B, then power of C. This will be the brightest. In the last question, C was the brightest. Here A is the brightest. Okay. And if you get this kind of question, there was no need to do all this. How much ever this rating is, give 220 volts. See, this will be 100, this will be 50, this will be 25, because everyone is getting 220 volts. Okay. I hope you understood. So in this session, it was only this much. We'll meet up in the next session where we'll be doing combination of resistors part 1. Again, I'll be doing this particular thing, combination of resistors, in 2 parts, where in the first part it will be very basic, series and parallel and Wheatstone bridge. Now series and parallel is something which you have already studied in your 10th standard. It is completely similar. There is no difference in that. Maybe there will be some questions which will be, when we'll mix series and parallel, they'll become a bit tough. But again, the concept is same. And then we'll be studying a new thing, that is Wheatstone bridge. This is new and important as well. In the next session, where I'll be doing next to next session, combination of resistors part 2, there I'll be taking complex questions. Most probably those questions will not come in your boards, but they are from the competition point of view. Okay, the fundamentals, how to solve those kind of questions, we'll clear in next to next session. All right, both the sessions are going to be very important because from combination of resistors, majority of the questions are there. In entire electricity, whatever questions you will get, combination of resistors is the most part, because whether you have to calculate current, or you have to calculate potential difference, or you have to calculate energy, or you have to calculate power, they will give you a circuit. In that circuit, there will be a lot of resistances which will be connected in any way. You need to find the net resistance. You should know to find the net resistance, then only you can find all other things. So these 2 sessions, the next 2 sessions are very important. All right. I hope you liked today's session, you understood today's session. If you liked it, do press the like button. Share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. Along with that, do not forget to visit our website www.v-learning.in. All these sessions you will get there. Along with that, you will be getting session notes, lecture notes also. All right. We'll meet up in the next session. Till then, keep learning from V Learning. All the best.